I guess people are going to join late today because Monday morning, na first day. Good morning. Okay. So first, let me quickly review what we did so far. Meanwhile, I guess others will join. In a few minutes, we'll start. So, so far, we have gone through object-oriented concepts in the last class. As I told you people, this object-oriented concepts basically we use them or we apply them in the programming, right? As we have discussed, these concepts from where they have been derived, yes, the object-oriented concepts from where they have been derived. Uh, I'm talking about the concepts from where they have been derived. We are talking about an object, but object-oriented concepts from where they have been derived. Yes. So these concepts actually they have been derived from the real world. Yes. You know, the world in which we live, it is completely based on object-oriented concepts. And you know, in the object-oriented concepts, who plays the key role? Who is an important actor? Yes. You see, object plays a key role in the object-oriented concepts. We got object-oriented features, right? What are the object-oriented features? Can you people talk about the object-oriented features? what are the object oriented features? Yeah, people who have just joined, I'm just trying to review what we did in the last class. Yeah, that's it. Okay, inheritance, yes, polymorphism, and abstraction, encapsulation. So these are the various object oriented features. Yeah, fine. So today we'll implement the object oriented concepts in the programming. That is, we are going to work with this object oriented programming. As I told you people in the last class, object oriented programming means, the programming wherein where we use object oriented concepts, the programming in which we use object oriented concepts. So we'll take an example. We'll consider a small example. You see, already I was talking about this online bank app. You see, let's say you have been given the task of writing the Java code or a Java program to store this savings account details. Okay. Yes. Okay. Sanket, I've just started with the concepts. Okay. We are talking about programming. We just started. So yes, what is your task? Let's say you've been told to write the Java code or a Java program, I can say, to store object, sorry, the savings account details. Okay. So this is your task, let's say. So how will you start? Yes, in the Java programming language, using Java programming language, how will you start? What you do? No problem. Yeah, I just started actually. So let's see what to do. So first of all, how will you start? What you need to do is you need to, okay, when I say you have to store the savings account details, you see, first of all, we have to think about everything in terms of objects here. First of all, can I say savings account is an object? Yes, of course it is an object. So how can you identify an object? I can say properties and behaviors. Okay. Okay. So it is an object, I can say. Now, when I say details of the savings account, so that means it will be properties of the savings account object. Okay, the properties, they represent the savings account, the details here. You can say properties, they represent the savings account here. So they represent the details. So what are the details of a savings account object? The properties, or we call it as a state here. Okay, properties or a state of an object. So generally, what details of the savings account object generally will be storing? You see, you'll have account number, balance, let's say status, say PIN. You may have several properties, but you see, for this example, I'll consider just these four different properties. Okay, I'll consider the following four properties of that account object. So the details here, these are the details, let's say, which I have to store. These are the details, let's say, which I have to store. So this is your task. So you have to write a Java program to store this savings account details. You see, this account is a object, a real world object. Savings account is a real world object. So we have to store this object details. So how will you start? What you will do? First, you have to identify the properties. Okay. So if we talk about only data, so you have to identify the properties. Now we did that. So next thing, what to do? So how will you store data in Java applications? Where exactly the data is stored in the Java applications? You know what? Let me tell you one thing. Every application, it deals with data. Every application, basically, it deals with data. Data plays a key role. Application always works with data, either processing the data or storage. Okay, processing means manipulating the data, or it will be storing the data. So it will be dealing with such things. It will be dealing with such things. Yeah. Okay, so here, whenever you've been given a task of storing a real world object details. Okay, whenever you've been given a task to store the real world object details, so what you need to do is here, you have to create a Java object. Whenever you need to store any real world object details here in the Java applications, what you have to do, please listen to me carefully, you have to create a Java object. You have to create a Java object. Yes, you have to create a Java object. So here, what is this Java object? When we talk about a Java object, you can say that this Java object is a software object, I can say. So it represents a real world object. It represents a real world object. Java object, it holds the data a real world object. It holds the data. It holds the data related to a real world object, I can say. Technically speaking, I can say that a Java object is an instance of a class, we say, of a Java class. Okay, so we need to create a Java object. We need to create a Java object in order to store a real world object details here. In order to store real world object details. So in order to store that savings account object details, so we'll create a Java object. But how to create a Java object? That's the question. How will you start? How will you start? In order to create a Java object, you know what? First of all, you need to define a Java class. You need to define a Java class. So, what is a Java class? What is a Java class? You know, I can say that a Java class, yes, can someone define this Java class? Yes, can someone define a Java class? Okay, let me read out the answers. So class is a blueprint. Okay, good. It's a blueprint. Okay, model for creating objects and does not exist physically. Okay, okay. So most of them. Okay, it's a collection of data members and methods. Okay, yeah, very good. So whatever you said, all of you, yes, it's exactly right. That means you people have studied the tutorials. You have gone through the tutorials. I'm happy. Okay, so I can say that class is a blueprint of an object. Class is a blueprint, right? It's a blueprint of an object. In other words, I can say that, and not only other words, actually, class is a template. Class is a template for creating objects. I mean Java objects. Okay, when I say objects, okay, especially at least today, I'll keep on using the term Java objects. Java objects. From next class onwards, I'll say only, or even in this class, I guess by the end of the class, I'll say only object and class. Okay, fine. So this term becomes redundant. I can say that class, it represents set of similar objects, set of similar Java objects, I can say. So I guess this should be enough. Yes, of course, in the Java class, you'll have it's a collection of what is it? It's a collection of methods. Okay, collection of methods, of course. We'll have variables and methods. Yes. So now that means from this discussion, what you need to understand is that in order to create an object, you know, first of all, what you need to do from this discussion, what you understood, in order to create an object, first of all, can we directly create an object, or what we are supposed to do? First of all, we need to define a class. Yes, we need to define a Java class first of all. So, and then with the help of the class, we can create an object. So to make you people understand it easily, here I'll give you an example. Let's say you got a plot, PLOT plot. Okay. So here you want to construct a building in this plot. So what is the first thing you're going to do? So what you'll do if you are supposed to construct a building, so what is the first thing you'll do? Uh, Even before you lay the foundation, you have to do one more thing. What is it? Okay, let's say we have the dimensions. So what are we supposed to do? Yes, you need a plan. You need a plan, or I can say a blueprint, right? So in that plan, you need a plan for the building. You see, in that plan, you'll have the description of that building. The plan gives you a conceptual image of that building which you want to construct. The plan will give you the conceptual image of the building which you want to construct. Okay, yeah. So you'll have the complete specifications about the building in the plan. So the plan describes the building, the dimensions of the building, you know, the every detail. Okay, how many rooms you'll have in that building, even in then again what is the dimension of each room in that building. Every detail you're going to get, right? So based on the plan, what you're going to do, we'll construct a building. So you'll hand over this plan to the constructor or the builder. So they will construct the building for you people. The builders will take this plan, and based on the plan, they'll construct the building. Based on this plan, they're going to construct the building. Yes. So you see the relationship between the plan and the building. Okay, you have a similar relationship between the class and an object, I can say. So based on this plan, how many buildings can we construct? Yes. So based on that plan, you can construct any number of buildings. So all the buildings, you know, which are constructed based on that plan, they look similar. All the buildings which are constructed based on that plan, they look similar, I can say, right? But they are not same exactly. You can say they are similar. Yes. Fine. You see, a similar relationship exists between a class and an object. So first of all, in order to create an object, we need to define a class. In order to create an object, first of all, we need to define the class. So class is a blueprint for creating objects. Class is a blueprint for creating objects. So class is a template. Sorry, class is a blueprint which describes that object. In other words, we can say that class is a template for creating objects. Class is a template for creating objects. That's it. Fine. So now let's start working with this example. So we have got a task. We need to write a Java program to store this savings account object details. So we have a real world object. Now we need to store the real world object details using a Java program. So for that we have to create a Java object. But in order to create a Java object, first of all we need to define a Java class. So let's start with defining a Java class. Okay. So let's define a class. So you see we have new class option here. You know that. So I'm defining a class. So I'll give this name a savings account. Once again, I'll show you if you missed creating a class. You see, make sure that you select the source folder, right click on it, you have new class option. Yes, you got new class option here. Yes. Now select this option. So we will give a name to this class. What is it? Savings account. Savings account. Okay. I'll click on finish. So you see, now we have a savings account class. What's the next thing we need to do? After defining the class, you see, in that class, for this properties, we need to declare variables. For this properties, you see, whatever the properties you got here, for this properties, we need to declare variables. You see, for each property, actually each property has got a value, right? For each property, you'll have a value. So in order to store that value in Java, we have to declare variables. You know that. That is the option which you got. We have to declare variables in Java. So that is the option which you have. So let's do that. You know, for in order to store that account number, so I'll declare a variable here for that property account number. So I can say that in other words, the properties of that object, we represent them as variables here, or we call them as fields. So for account number, I declared a variable. For balance property, to store the balance property value, I'll declare another variable. Let's say float balance. And you see, for status, I'll declare another variable. I'll make it string type. String means set of characters. Okay. So whenever you have to store set of characters, we can use this string type. Next pin number, say integer value. So this way you see the properties of an object, they're represented as variables here. So you see they're known as fields or non-static variables, or they're also known as instance variables. So all means the same here. All means the same. So what's next? Okay, the next thing what we'll do is here we got a class. Okay, now we need to store the data. In order to store the data, so what are we supposed to do here? Yes, we need to create an object. We need to create objects. Okay, we need to create an object now. We got a class, right? So class, it represents, it is a template for creating objects. So let's create a Java object for this. You see, let's ask Java to create an object. So I'll write this code. So this statement, you know, you see where I've written it in the test class, we have written the statement. This statement here, it instructs, it's an object creation statement, I can say. It instructs your JVM to create an object. It instructs the JVM to create an object. So the JVM, what it does is, yes, it will create an object, and let's see how exactly it looks like. So JVM, what it does is, when we instruct the JVM uh, to create an object, first of all, the JVM allocates a block of memory for that object. Immediately, first of all, the JVM, it allocates block of memory for that object. And you know, as part of that object, the JVM will also allocate the memory for this variables. The JVM will also allocate the memory for this variables. Okay, so that means now this variables, the memory for that variables is allocated as part of this object itself. You have this variables like account number, balance, we got status, and what is the last thing, pin. This way the memory is allocated for that object. As part of that object, you see, the memory for that variables which are declared in that class are also allocated. Okay, Now, the reference to this object will be stored in a variable called as account. The reference to this object will be stored in this variable called as account. That's it. Okay. So this account is actually called as a reference variable, or we say it's a handle. You can call it as a handle to that object. You can consider it as the handle to that object here. Yes. Okay. So this variable is declared as part of that object creation statement itself. I'll show you people. You see here, as part of this object creation statement, I've declared that variable called as account. So we call it as a reference variable. Now, if you want to access that object, so we need to use this reference variable itself. So this reference variable, it holds the reference to that object. It holds the reference to that object, I can say. So now you see, we didn't store the data here, right? We didn't store the data. Someone is joined through the phone. Could you please make sure that your mic is muted? So there is a lot of background noise. Someone has joined through phone. Could you please mute your mic? Phone caller, please mute your mic. Okay. So now you see, this block of memory itself is called as an object here, because now it is going to hold real world object details. This block of memory, it is going to hold the real world object details. Yeah. Okay. So now we need to store the data into this object. Into this object means the variables which are part of that object. We have to store the data into the variables which are part of that object. So let's see what to do. As I told you people, we need the reference to access that object. So let's use that reference. So I'll do this. Account dot account number equal to something like this, 101. So account dot balance is equal to 5000. Account dot status, let's say, is equal to active. Account dot pin equal to 1234. So now what happens, you see, all this data, it will be stored into this object, I can say. All this data, it is stored into that object. 101, 5000, active. Yes. So this way, you see, whenever you're supposed to store a real world object details, so you will create a Java object and you'll store that data in that Java object. Now, we can read the data from that object again. Whenever you need it, you can read it. You see, uh, I'll just add some labels, I can say, or just some messages before I print the values. You see, this is text content. So I want to display account number. So before that value, I'll print this text message. Plus, how will you read that account number? You have to use the reference again, account number. Similarly, sorry, you'll do the same for other values. So for balance, I'll do this account dot balance status. Pin. That's it. So let me run this code once. You see, yeah, you got the data. So what we did, we have defined a savings account class, and you see, in the main method of test class, we have written this code to instantiate the savings account class. That means we are creating a savings account class object. Then in that savings account object, we are storing some data. After that, you see, we are reading the data which is stored in that object. So hope you people got it. So any doubts in this regard, please let me know. Yeah, you see, if you remember, we have discussed about type conversions, right? Implicit and explicit conversions. Yeah, you see, you'll find that okay, we are storing that integer value, but though for integer value we don't use suffix f, even if you use suffix f for a float value, it will not be displayed when you print it. Okay, it will not be printed. F will not be printed. Even if you add that prefix suffix f, it will not be printed. Okay, But here this is an integer value which you are assigning, right? It's not a floating point value. So in that float variable can take an integer value, you know that. So we saw that implicit casting type conversions, if you remember. Yeah. So any other questions? Okay, so I have a question for you people. What if we have to what if we need to store another savings account details? So we got another savings account, so we need to store that savings account details. So what to do? We got another savings account, so we need to store that savings account details. Yes, so what we need to do here, so we need to create another object, create another object. Okay, so let's try to do that. So in order to store another savings account details, so we'll create another savings account object here. Okay, you see, I'll do this again. We have written the statement, so this is object creation statement, I can say. This is actually object creation statement. Yeah. So now this statement, you see, it instructs your JVM to create another object. This statement will instruct the JVM to create another object. Again, a block of memory is allocated for that object, for the second object which you got. And see here, this object's reference, you'll find that it is stored in a reference variable account 2. It is stored in a reference variable account 2. Yeah. So this is the reference variable. So account 2 is a reference variable which refers to that second object. So if you want to access the second object here, you need to use that account 2 reference variable. If you want to access the first object, use that account only account reference variable is there now. Use that reference variable. That's it. So let's try to store some data into that second object. So you see, I'll just copy this code, which is almost similar. This time instead of account, I'll say account 2, account 2, 2, 2, 2, account 2 dot account number. Let's say 102. Account 2 dot balance is 10,000. Let's say it is active. Let's say 3456. So this is the data. So now this values, you see, they'll be stored into this variables of that second account object. 1, 2. Say 10,000. Say active 3456. Okay. So in that second object which I've created here, so we got another account object details here. So have you people noticed it? Now you see, we have created two objects here, two Java objects using the same class definition. Each time we create an object, you'll find that the memory for that variables or fields, I can say, the memory for this variables or fields, you'll find that it is allocated separately. Every object has got its own it has got its own copy of these variables. Every object has got its own copy of variables here. You got the point? So you have two objects, now you have two copies of this instance variables. Two copies of this instance variables. So this way, every object will have its own copy of this instance variables. Instance variables means, you see, I'm talking about the variables which are specially declared here in the class, or we say fields or non-static variables. So each time we create an object, the memory for these variables will be allocated separately. This is part of that object. The memory for these variables will be allocated. Yeah. So that means if I create 100 objects, then how many copies of these variables will be available? Yes, you'll have 100 copies of these variables. So every object has got its own copy of variables, right? Yeah. Now, why every object needs its own copy of this variables here. So why each object has got its own copy of this variables? What do you people think? Why every object has got its own copy of variables here? No, I'm saying why every object has got its own copy of this variables. Each time you create an object, yes, that's right. That's right. Yeah. Because you see, each object it has got its own data, which is different from another object, right? Every object has got data, which is different from another object. So no two account numbers the same, right? So if you consider the account number, you see the property value, that account number will change from object to object. The account number property value will change from object to object, right? So it is different for each object. So that's the reason why you need a separate variable here to store that value. You need a separate variable to store that value, you can say. Yes. So balance is also different. So that's the reason why every object will have its own copy of this instance variables, because the data is different from object to object. So this property values will change from object to object. Yes, that's the reason why every object has got its own copy of this variables. So is it clear for everyone? Can I have yes or no? Okay, good. Thank you. Good. Thanks for the response. Next, now what we'll do is here, okay, we'll dig into the details of object creation statement. So we'll try to understand this object creation statement. We'll try to understand the object creation statement here. Object creation statement means, you see, this is a statement which instructs JVM to create an object, right? Yeah. So this object sorry, this object creation statement, it can be divided into three parts. Okay, the object creation statement can be divided into three parts. So the first part of the object creation statement is is this. So declaration of reference variable. You see, we are declaring a reference variable here, savings account of account. What is this account? Account is a reference variable. So most of them, they think that this variable itself is an object, but it is not an object. It is just referring to an object. It holds a reference to an object. It is a handle to that object. You can think of it as a pointer, but not exactly pointer. We don't have memory address of that object here. We say only it has got a reference to that object. So sorry, you see, this reference variable is actually similar to any other variable. For suppose you have int I. You can relate that account variable to I. So like I, account is also a variable here. Into this variable I, what value we can store? Yes. Into this variable I, what value you can store? An integer value. How we are saying, how can we say that we can store an integer value? Because before this variable name, we got the data type details. So before the variable name, we got the data type details. Then you see here, we got this account variable. So into this reference variable, what value can we store? Into this reference variable, what value can we store? So we can store savings account class object reference. We can store savings account object reference, I can say. We can store savings account object reference. Not properties, object reference. In that object, in turn, you have the memory allocated for that variables of, which are declared in the class. Okay. So this account variable, it can take or it can hold savings account object reference. Like I, account is also a variable, but it is a special type of variable, I can say. Always we can store an object reference. So you'll find that we can store, say in this case, we can store savings account object reference always. That's it. Now the second part of this object creation statement, you see, is this new keyword. So as part of the object creation statement, I'm sorry, as part of the object creation statement, we'll use this new keyword. So what is the significance of this new keyword? So can you people explain why we use this keyword new? Yes. Yes. You know, new is a keyword. Keyword means it's a predefined variable in Java. It's a predefined variable in Java, which has got which has got a specific meaning. It has got specific meaning here. Okay, it has got a specific meaning. So, you know, this new keyword, I can say that we use this new keyword to instruct the JVM, yes, to create an object. Okay, yes. So this new keyword is used to instruct the JVM to create an object, yes, or create an instance, or create an instance. New keyword is used to instruct the JVM to create an object, or I can say to create an instance. Instance or object means the same, both means the same. Okay, so whenever the JVM it comes across this new keyword, whenever the JVM comes across this new keyword, what it does, it immediately creates an object. So it allocates a block of memory for that object in the, it will allocate block of memory for that object. Okay, it allocates a block of memory. Yes. So the new keyword is used to request the JVM to create an object. Is used, sorry, new keyword is used to request the JVM to create an object. Okay. Next, you see, the last part of this object creation statement is savings account of brackets. So, what does it means? Can someone explain this part of the statement? Can someone explain this part of the statement here? Mm, okay. Yes. Actually, I can say that we are calling at constructor. Yes. You know, it is actually called to the constructor. So we are calling the constructor. This is a call to the constructor. Okay. So this way we can divide this object creation statement into three different parts. Just a minute, please. Just a minute. Sorry, just a minute, please. Just a minute. Yeah, I'm sorry. Okay. So hope you people can hear me, right? Okay, good. Thank you. So this way you say the object creation statement can be divided into three parts. So first, declaration of reference variable. So that reference variable is used to store, it is used to store that object reference so that later on we can use that reference to access that object. Next, we have new keyword which is used to request the JVM to create an object, and then we got that statement after that new keyword. Actually, it is a call to the constructor. It is a call to the constructor. I'm saying it's a call to the constructor. Okay, it's not a constructor, but it is a call to the constructor. So we are invoking the constructor. Right? You're basically invoking the constructor. Yes. So what is this constructor and all? We'll talk about it later, okay? Don't worry about the constructor now. So this is how the object creation statement is divided. Yeah, fine. So generally constructors are used to initialize an object, I can say. Constructors are used to initialize an object. What does that mean? We'll see. But here I have few questions for you people. Okay. Yes. Try to answer these questions. Let me see how far you understood this object creation statement. So just observe that line number 6. Just check that line number 6. What exactly happens if that statement executes? What do people think? What exactly happens if that statement executes? Okay. Can I say that an object is created? No? Yes. You see, in this case, yeah. So object is not created, but we're only declaring a reference variable, I can say. So this is a legal statement. It's a valid statement. There is no error in that statement. It's absolutely fine. But if we do this here, then it indicates that we have just declared a reference variable. It's a reference variable. Account 3 is a reference variable. So into that reference variable, we can store savings account object reference. That's it. Yeah. Next, yeah, object is not created. Okay. Hope everyone got it. We didn't create an object. For suppose if I do this, now check this line 6. Check this line 6. Highlighted code. So if we do this, what exactly happens? Okay, a new object is created without a reference. So you're saying that an object is created definitely. Okay. What about others? Okay, it's only a call to the constructor. Any other answer? Yeah. Okay, object is created. So can we access that object? That newly created object. So can we access that object? No. Yes, we cannot access that object. That's right. You know what? Definitely object is created. There is no doubt in that regard. Object is created. But you see, you'll find that there is no reference to that object. There is no reference to that object. We don't have any reference to that object. That means you cannot access that object. So that object is not reachable or it is not accessible because we didn't store that newly created object reference in a reference variable. Yes. Okay, good. So hope you people got it. Fine. So any questions in this regard? Okay. So let's move on. Now, you see, as I told you people, as part of the object creation statement, you see, this part of that object creation statement. So we are calling the constructor, right? So what is a constructor? And so basically, why do we use this constructor? Can someone explain this? What is a constructor? Okay, constructor is similar to a method, okay, that is used to initialize the instance variables. Okay, yes, that's right. Used to initialize the values to the variables. Method with this with the same class name. Okay, good. So what you said, I do agree. You're right. So your answers are right. So let me give some notes on this constructors also. So constructor is a special method, so whose name is same as class name. Constructor initialize is used to initialize an object. Constructor is used to initialize an object. Okay. So initializing an object means what? Initializing, or we say initialization. So you can make a note of it. Initialization means assigning initial values to the instance variables which are part of the object. Assigning initial values to the instance variables which are part of the object. So each time we create an object, you know that the memory for that object is allocated. Sorry, yeah, the memory is allocated for that object. And as part of that object, the memory for that instance variables is allocated, right? Yeah. So assigning some initial values to that instance variables which are part of the object. That is initialization. So generally, it is recommended that we use a constructor to initialize an object. It is recommended that we use a constructor to initialize an object. Okay. So you know what? I'm saying that as part of the object creation statement, we are calling the constructor. It's a call to the constructor, right? So, but where is the constructor? So, did we define any constructor in the class? If we got a constructor, it has to be in the class. So, do you see any constructor in the class here? Yes. No, right. Then, if there is no constructor in the class, then how come we are able to call that constructor? How can we call the constructor which is not existing? Default constructor. Yes. You know what happens in the class? If we don't add any constructor in the class, there is no constructor. During the compilation, the compiler, what it does is it adds a default constructor. During the compilation, the compiler will check whether there is any constructor defined in the class or not. The compiler will check whether there is any constructor defined in the class or not. So if the compiler fails to find a constructor in the class, if the compiler fails to find any constructor in the class, then the compiler adds a default constructor, I can say. Compiler, it adds a default constructor. Yes. So during the compilation, if the constructor fails to find any constructor in the class, then it adds a default constructor. It adds a default constructor. So I hope you people are making a note of this. Please maintain a running notes, right? Please maintain a running notes. I'm assuming that you people are making a note of all these points. Please do that. Okay. Yeah. So during the compilation, if the compiler fails to find any constructor in the class, then what it does, it adds a default constructor. it adds a default constructor. Okay, so you know how the default constructor looks like. This is your default constructor. You know what? I can say that default constructor is not of much use for us. So if you want to initialize an object, then it is better to use a parameterized constructor, which is more flexible, I can say. I can't say completely not, the default constructor is not completely useless, but the more flexible one here is parameterized constructor. So you have a default constructor, and you can also define a parameterized constructor. As of now, this is a default constructor. So let's add a parameterized constructor which we can make use of to initialize that object. Which we can make use of to initialize the object. So now I'll I'll give you people sorry, I'll show you people an option to easily create a constructor. I'll show you people an option to easily create a constructor. Okay. So if you are using an Eclipse ID, it's very easy adding a parameterized constructor. Okay, you can easily add a parameterized constructor. Please make a note of it. Adding a parameterized constructor using Eclipse ID. Adding a parameterized constructor using Eclipse ID. Please make a note of it. So in order to add a parameterized constructor using Eclipse ID, so first of all, make sure that the cursor is in the class. You see, I've placed it after the default constructor. Right click on it. You'll find a source option. If you right click on the cursor, you should see source option. Okay. So under the source, you see, we have this option under the source. You should see this. What is it? Generate constructor using fields. Generate constructor using fields. Just select this option. When you select that option, what is it? Generate constructor using fields. Generate constructor using fields. So when that option is selected, you see, you'll get a pop-up window here. You see, it says select fields to initialize. So which fields you want to initialize? So you see by default all the fields of that class are selected here. And by default all the fields of the class are selected. Okay, so that means you want to initialize all these fields. Now you can click on OK. Click on OK. See, you got a parameterized constructor. So you got a parameterized constructor. So the first one is a default constructor. The second one is a parameterized constructor. You see, you'll find super call here. Remove the super. Remove that super. We'll talk about it definitely, but later, not now. Yes. You see, what is the difference between a default constructor and parameterized constructor? So what people have observed, what you people have noticed here, can you people tell me what is the difference between default constructor and parameterized class constructor? Okay, so the default one has got no parameters. For the parameterized constructor, we got some parameters, right? Okay. So what exactly are parameters? Let me give you people some notes on this parameters. Parameters they represent or parameters they use to specify the number and the type of values they are used to specify the number and type of values which we need to pass to the constructor or a method. Even for the method the meaning is same. Okay, parameters they use to specify the number of values and type of values I can say which we need to pass to the constructor or a method. Constructor is also a method. It's a special method whose name is same as the class name. Constructor is also a method. It's a special method. Its name is same as the class name. Yes. Okay. So parameters here they represent the number and type of values. You understood this, right? The number of values and what type of values which we need to pass to the constructor. So that is specified by the parameters here. So parameterized constructors are predefined values. No, not at all. Parameterized constructor means it's a constructor which takes some parameters. That's got parameters. And as I told you people, the parameters basically they are used to specify what type of values and how many values that constructor takes. Okay. Now in our case, you see the constructor which you got here, the constructor which you got here. So this constructor, for this constructor, we got how many parameters? For this constructor, we got how many parameters? 4 parameters. For this constructor, we got 4 parameters. That means it indicates that this method it takes 4 values. This method it takes 4 values. You know, not only the number of values, but you see this constructors they also specify the type of values. So what type of values this constructor takes? You see, one integer, one float, one string, and integer value. These are the values that method that constructor takes. So when we invoke this constructor or when we call this constructor, when we call this constructor, you have to pass 4 values because it takes 4 values. Okay. Now you see they have parameters. I said parameters means they're just variables, temporary variables. The names of these parameters they're same as the instance variables, right? The instance variable names and the parameter names are same. Can we do that? Yes, it is possible. Not a problem. I want you people to understand that here the parameter names and instance variable names are same. Okay. Yes. Now, what is the purpose of the constructor? What did I say? It is used to initialize an object. You see, just now we have discussed about that objects. When we talk about an object, you see, every object has got its own copy of instance variables, right? Each object has got its own copy of instance variables. Every object has got a reference. Now the constructor, it is supposed to initialize which copy of this instance variables. That means a copy of first object variables, a copy of second object variables. So which variables have to be initialized by this constructor? Which object values have to be initialized? Because we have two different copies of variables, right? Every object or each object has got its own copy of variables. So now the constructor, it should understand it is supposed to initialize which object. Not only that, but it should have a reference. to that object as well. You see, this is the reason why when the constructor is invoked, to that constructor, implicitly that newly created object reference is passed on. When the constructor is invoked, implicitly, that means internally, the newly created object reference is passed on, and it is stored in this variable. It is stored in this variable. So this here, you see, what is this? Make a note of it. In context of constructors, I can say that this this holds the reference to the object, or I'm sorry, just a minute. When the constructor is invoked, to that constructor, implicitly the newly created, I'm sorry, don't make a note of it. When the constructor is invoked as part of newly created, as part of, I'm sorry, object creation statement, as part of object creation statement, when the constructor is invoked as part of object creation statement, so to that constructor, implicitly that newly created object reference is passed on implicitly, so that the constructor can use the reference to access that object and initialize it. That's it. When the constructor is invoked, as part of object creation statement, you know that constructor is always invoked as part of object creation statement. So when the constructor is invoked as part of object creation statement, so then what happens? You see, to that constructor, implicitly the newly created object reference is passed on. To that constructor, the newly created object reference is passed on implicitly, I'm sorry. To that constructor, newly created object reference is passed on implicitly. Passed on implicitly means, what do we mean by that? I'm saying to that constructor, the newly created object reference is passed on implicitly. Implicitly means, yes, automatically. That means we don't need to write any code for this. We don't need to write any code for this. So automatically, so when the constructor is invoked as part of that object creation statement, you see that newly created object reference is passed on. It is passed on implicitly to that constructor, and it is stored in this variable. I didn't It's passed on implicitly to that constructor. Newly created object reference is passed on implicitly, and it is stored in this variable, I can say. So the constructor can use the reference to access the object and initialize it. Yes. So most of them will be confused with this keyword. So that keyword, I can say that it holds that newly created object reference. It has got the reference to that newly created object, which it has to initialize. So in simple terms, I can say that this keyword, I give you this note so that you can remember this keyword or this variable. This here, I can say that it holds the reference to the object which has to be initialized by the constructor. Which has to be initialized by the constructor. Sorry, this holds a reference to the object which has to be initialized by the constructor. So we say current object reference, the newly created object reference. Okay. Now let me show you people how to use that parameterized constructor. Okay, I'll show you people. You see, whatever the code which I have written here, I'll just comment it. That initialization code, I can say. Initialization means the code which is used to assign some initial values to that object. So that initialization code, I've commented it. Now this time you see, as part of that object creation statement, so we are calling the constructor. You see, we are passing the values to that constructor. We're passing the values to that constructor, I can say. Yes. You see, we are passing 4 values. So actually we call them as arguments. We're passing 4 values or arguments to that constructor, I can say. Arguments means that values which we pass to that construct, to that method or a constructor. We call them as arguments. So these values which we are passing to this constructor, you see, they are stored into this variables. Okay, or parameters. They will be stored into this parameters or variables, I can say. Yes. Okay. Now you see, now the values which are stored in this variables are this parameters. The values which you got here in this parameters, we need to assign them to that instance variables. As of now, you see, when the constructor is called, to that constructor, these values are passed and they are stored in this variables or parameters. You can say the values, they're basically stored in that parameters. Now the values which are in the parameters means just temporary variables which are only visible or accessible within this method. This values which are stored in the parameters, they're just accessible within this constructor, within this method, that is constructor here. Okay. So that values, now we have to assign them to the variables, instance variables which are part of the object. We have to assign them to the instance variables which are part of the object. Okay. So you see, this is where you're going to use this reference. This means it refers to the newly created object. This holds the reference to the newly created object, I can say. This holds the reference to the newly created object. Yes. So here, that values, we are assigning them to that instance variables. We're able to access the instance variables and we are assigning those values here. That's it. Okay. So now you see the second object also, while creating the second object, we'll call that parameterized constructor and we'll pass that values. We'll pass that values. So in both the cases, we are calling the constructor. Okay. Yes. So I have a question for you people. Listen to me carefully. So you see, as part of this object creation statement, you see we are calling the parameterized constructor. How can I say that we are calling parameterized constructor? Because we are passing some values, input values. So that only parameterized constructor will take that input values. Only parameterized constructors will take input values. Default constructor will not take any values. So I can say that we are calling parameterized constructor. So you see the constructor, parameterized constructor will be invoked. In the parameterized constructor we have this variable. Now this here, it refers to which object? It refers to which object now? This here, it refers to which object? This refers to which object? Yes. Not both. As I told you people, I gave you a statement. I'm not sure how many of you people have made a note of it. When the constructor is invoked as part of object creation statement, to that constructor, newly created object reference is passed on implicitly and it is stored in this variable. I guess this notes is very simple, easy to understand. So this clearly explains what exactly you have in this variable. So as part of first object creation statement, as part of this object creation statement, we are calling the constructor. So when the constructor is invoked, you see to that constructor, newly created object reference. Now in our example, that first object, you see that newly created object reference is passed on implicitly to the constructor. It is passed on implicitly to the constructor and it is stored in this variable. Now this here, it refers to the object. Which object? The first object. Because as I told you people, see, I was talking about calling the constructor as part of first object creation statement. So in that case, basically this here, it refers to the first object, you can say. Okay. So for suppose, hope everyone got it. Okay, as of now, this here, it refers to the first object. So why the constructor needs that object reference? Because the constructor should access that instance variables and initialize them, right? That instance variables, they're part of the object. So how the constructor will be able to access that instance variables and initialize them? You see, it needs that object reference. So that's the reason why that object reference is implicitly passed on to the constructor. So if you call the constructor as part of first object creation statement, in that case, you see this keyword here, or this variable, I can say that it holds the reference to the first object. That's it. So if we call the constructor as part of second object creation statement, if we call the constructor as part of second object creation statement, so if we call the constructor as part of second object creation statement, so in that case, this here, it refers to which object? This keyword, a variable, it refers to which object? Second object. Okay, second object. That's right. Account to. This way, each time we call the constructor, you see, as part of that object creation statement, we call the constructor, right? So to that constructor, the newly created object reference is passed on, so that constructor can use that reference. You see, constructor is using that reference. This dot balance means here, you see, we are referring to that variable which is part of the first object now. Okay, if it is this is part of that object, I can say. Yes. So each time this constructor is called, that reference which is stored in this will be different. So that newly created object reference is passed on. Yeah. Okay. So let me run this code. So once we'll test it, you see, I'm only printing that first account details. We are printing only first account details. You see. So here it's working. We're using the constructor to initialize the object. It works. Yep. So hope you people got it. So any questions? So anyone got any questions? Please let me know. Okay, good. So I have a question for you people. So what is the advantage of using the constructor here? So what is the advantage of using the constructor? What is the advantage? So is there any advantage of using the constructor? Okay, code reusability. Yes, that's right. That is one of the advantages. Okay, and what else? Okay, so let me explain it. So I'll explain it. You see, so just imagine, for suppose here, let's say we are not using the constructor. If we don't use the constructor, then how many lines of code we have to write additionally to initialize that object? How many lines of code additionally we have to write to initialize this object? 4 lines. Yes. So that means, okay, if you have two objects, it is 8 lines of code. So just imagine if you were to initialize 100 such objects, then how many lines of code additionally you'll write to initialize the object? 400 lines of code, that's right, right? We have to write additionally 400 lines of code, yes, if you're not using the construct. For suppose here, what if we use a constructor? You see, if we use a constructor, we have a constructor which is defined with 4 lines of code. Now, this constructor which you got here, so we can use it to initialize any number of savings account objects, I can say. We can use it to initialize any number of savings account objects. So for all that objects, you're going to use the same constructor. Okay, yes. In this case, in our example, we are creating two objects. So each time we are creating an object, you see, we are calling the constructor. It's part of that object creation statement, you know that. So when that constructor is invoked, when the constructor is invoked, you see to that constructor, that value is a constant, it is initializing it. You see, in order to initialize both the objects here, you see, using the same constructor, same lines of code. Even if you're supposed to create 100 objects, still you'll use the same constructor. That means same 4 lines of code. So it is highly reusable. So it is highly reusable. So now to initialize the objects of that class, we use that constructor. So we reuse it basically. That's it. It's reusable. Yeah. So is it clear for everyone? So you see, because of this reusability itself, you'll find that it is highly recommended that we use a constructor to initialize the objects. Use the constructor to initialize the objects. Okay, so any questions? Okay, so now you see what we did. In this class, we saw how to represent the real world objects. Basically, the real world object details, we are storing them in a Java object. So that real world objects here, they are represented using Java objects, I can say. Right? Yeah. So the properties of that object, properties of an object here, they are represented as variables. Properties of an object are represented as variables. The behaviors of an object, so we'll discuss about it in the next class. The behaviors of an object, we'll talk about it in the next session. So we'll try to implement this object-oriented concepts one by one. You see, as of now, today we saw how to create an object to represent a real-world object. So, and its properties also. Now in the next session, we'll see how to represent the behaviors of a real-world object. How to represent the behaviors of a real-world object. Okay. So I will stop it here today. Let's meet tomorrow and we'll continue our discussion. So you people understood how to use a constructor also today, right? So you people understood how to use a constructor also. Okay then, that's all. Thank you. Have a nice day all of you. Bye bye.